Swayam Prabha. Digital India. Educated India.
Now, next we are going to discuss artificial intelligence, where the mathematics we are using. First we have to learn AI. So, we call ourselves Homo sapiens, the man, the wise, because our intelligence is so important to us. For thousands of years, we have tried to understand how we think, that is, how a mere handful of matter can perceive, understand, predict and manipulate a world far larger and more complicated than itself. So, the field of artificial intelligence or AI goes further still. It attempts not just to understand, but also to build intelligent entities. So, AI is one of the newest fields in the science and engineering. The work started in the earnest soon after World War II, and the name itself was coined in 1956. Along with the molecular biology, AI is regularly cited as a field I would most like to be in by scientists in other disciplines. A student in physics might reasonably feel that all the good ideas have already been taken by Galileo, Newton, Einstein and the rest. So, AI on the other hand still has opening for several full-time Einstein and Edisons. So, AI is currently encompasses a huge variety of subfields ranging from general to the specific, such as playing chess, proving mathematical theorem, writing poetry, driving a car on a crowded street and diagnosing the diseases. So, AI is relevant to any intellectual task. It is truly a universal field. What is AI? We have claimed that AI is exciting, but we have not said what it is. So, in figure 1.1 we see the 8 definition of AI laid out along 2 dimensions. That is what we are going to discuss further. So, the definition on top are concerned with thought processing and reasoning, whereas the ones on the bottom address behavior. So, the definition on the left measures success in terms of the fidelity to human performances, whereas that ones on the right measure against an ideal performance measure called rationality. A system is rational if it does the right thing given what it is knows. So, historically all 4 approaches to AI have been followed, and each by different people with different methods. A human-centered approach must be in the part an empirical science involving observation and hypothesis about the human behavior. A rationalities approach involves the combination of mathematics and engineering. So, the various group have both disparaged and helped each other. So, let us look at the 4 approaches in more detail. Number 1, thinking humanly. Number 2, thinking rationally. Number 3, acting humanly. Number 4, acting rationally. First, thinking humanly. So, the exciting new effort to make computers think, machines with minds in the full and literal sense, and the automation of activities that we associated with human thinking activities such as decision making, problem solving, learning, the year of 1978 by Bellman, and thinking rationality designed by the Charnick and McDermott in the 1985, a study of mental faculties through the use of computational models, and Winston in the year of 1992 mentioned the study of computation that make it possible to perceive, reason and act. For acting humanly, Kurzweil 1990, the art of creating machines that perform functions that require intelligence when performed by people. In the year 1991 by Rich and Knight say that the study of how to make the computers to do things at which at the moment people are better In the Pool Echelon 1998 mentioned the action rationale of computational intelligence is the study of design of intelligent agents, and Nielsen said in the year of 1998 AI is concerned with the intelligent behavior in artifacts. So, these are all the some definition of artificial intelligence organized in 4 categories. Now, coming to the acting humanly. So, the Turing test approach. The Turing test is proposed by Alan Turing, was designed to provide a satisfactory operational definition of intelligence. So, a computer passes the test if a human is an interrogator after posing some written questions cannot tell whether the written responses come from a person or from a computer. So, here we discuss the details of the test and whether a computer would really be intelligent if it is passed. For now, we note that programming a computer to pass a rigorously applied test provides plenty to work on. So, the computer would need to possess the following capabilities. 1. Natural language processing to enable it to communicate successfully in English. Knowledge representation to store what it knows or hears. Automated reasoning to use the stored information to answer the question and to draw new conclusion, and machine learning to adapt to new circumstances and to detect the extrapolate patterns. Next, Turing's test deliberately avoided direct physical interaction between the interrogator and the computer, because a physical simulation of the person is unnecessary for intelligence. However, the so called total Turing test includes a video signal so that the interrogator can test the subject perceptual abilities as well as the opportunity for interrogator to pass the physical object through the hatch. To pass the total Turing test, the computer will need the computer vision to perceive objects and robotics to manipulate object and move about. Next, thinking humanly, the cognitive model approach. If we are going to say that the given program thinks like a human, we must have some way of determining how humans thinks. So, we need to get inside the actual workings of a human minds. There are 3 ways to do this: through introspection, trying to catch our own thoughts as they go by, through psychological experiments, observing a person in action, and through brain imaging, observing the brain in action. Once we have a sufficiently precise theory of the mind, it becomes possible to express the theory as a computer program. So, if the program's input output behavior matches corresponding human behavior, that is the evidence that some of the program mechanism can also be operating in humans. For example, Alan Newell and Herbert Simon, who developed GPS, the general problem solver, were not content merely to have their program solve problems correctly. They were more concerned with comparing the trace of its reasoning steps to trace of human subject solving the same problems. So, the interdisciplinary field of cognitive science brings together computer models from AI and experimental techniques from psychology to construct a precise and testable theories of the human mind. So, the rational agent approach is just something that acts. So, in the Latin, agent comes from the Latin is agere, to do. Of course, all computer programs do something, but computer agents are expected to do more. So, operate autonomously and perceive their environment and persist over a prolonged time period, adapt to change and create and pursue goals. So, a rational agent is one that acts so as to achieve the best outcome, or when there is uncertainty, the best expected outcome. So, in the laws of thoughts approach to AI, the emphasis was on correct inferences. Making correct inference is something a part of being a rational agent, because one way to act rationally is to reason logically to the conclusion that a given action will achieve one goals, and then to act on that conclusion. On the other hand, the correct inference is not all of the rationality. In some situation, there is no probably correct thing to do, but something must still be done. So, there are also ways of acting rationally that cannot be said to involve inference. For example, recoiling from a lot stove is a reflex action that is usually more successful than a slower action taken after careful deliberation. Next, the foundation of artificial intelligence. So, the philosophy is, can formal rules be used to draw valid conclusion? How does the mind arise from a physical brain? Where does knowledge come from? How does knowledge lead to action? So, these are all the possible questions may rise to think about it. So, Descartes gave the first clear discussion of the distinction between the mind and matter and of the problems that arise. So, one problem with purely physical conception of mind is that it seems to leave little room for free will. If the mind is governed entirely by physical laws, then it has no more free will than a rock deciding to fall toward the center of the earth. So, Descartes was a strong advocate of the power of reasoning in understanding the world. So, a philosophy now called a rationalism, and one that count Aristotle and Leibniz as a member, but Descartes was also a proponent of dualism. So, he held that there is a part of human mind or soul or spirit, so that is outside of nature, exempt from physical laws. Animals on the other hand did not possess the dual quality, so they could be treated as machines. So, an alternative to dualism is materialism, which holds that brain's operation according to laws of physics constitute the mind. So, free will is simply the way that the perception of available choices appears to the choosing entity. So, given a physical mind that manipulates knowledge, the next problem is to establish sources of knowledges. So, the empirism movement, starting with Francis Bacon's Novum Organum, is characterized by dictum of John Locke, is in the understanding, which was not first in the senses. David Hume's The Treatise of the Human Nature proposed what is now known as a principle of induction. So, that general rules are acquired by exposure to repeated association between their elements, building on the work of Ludwig Wittgenstein and Bertrand Russell. The famous Vienna Circle, led by Rudolf Carnap, developed the doctrine of logical positivism. So, this doctrine holds that acknowledge can be characterized by their logic theories connected ultimately to observation sentences that correspond to the sensory inputs. Thus, the logical positivism combines rationalism and empirism. So, the confirmation the theory of Carnap and Carl Hampel attempted to analyze the acquisition of knowledge from experience. So, Carnap's book The Logical Structure of the World defined an explicit computational procedure for extracting knowledge from elementary experience. It was probably the first theory of mind as a computational process. So, next we will go to the mathematics. What are the formal rules to draw valid conclusion? What can be computed? How do we reason with uncertain information? So, the philosophers stacked out some of the fundamental idea of AI, but the leap to formal science required a level of mathematical formulation in three fundamental areas. One is logic, computation and probability. The next step was to determine the limits of what could be done with the logic and computation. The first non-trivial algorithm is thought of the Euclid algorithm for computing greatest common divisors. The word algorithm comes from this study, and then this fundamental result can also be interpreted as showing that some function on the integers cannot be represented by an algorithm, that is they cannot be computed. So, this motivated Alan Turing to try the characteristics exactly with which function are computable and capable of being computed. So, this notion is actually slightly problematic because it is more complicated, and although decidability and computability are important to an understanding of computation, so the notion of a tractability has had an even greater impact. Roughly speaking, a problem is called intractable if the time required to solve instance of problem grows exponentially with the size of the instances. So, the distinction between the polynomial and exponential growth is come. Now, how can one organize an intractable problem? The theory is NP completeness. So, pioneered by Stephen Cook and Richard Kopp provides a method. Cook and Kopp showed the existence of large classes of canonical combinatorial search and reasoning problem that are NP complete. So, any problem class to which the class of NP complete problem can be reduced is likely to be intractable. So, beside logical and computation, the third great contribution of mathematics to AI is theory of probability. So, the Italian Girolamo Cardano first framed the idea of economics. How should we make the decision so as to maximize the payoff? How should we do this when others may not go along? How should we do this when the payoff may be far in the future? So, the science of economics got its start in the year of 1776 when Scottish philosopher Adam Smith published an inquiry into the nature and causes of the wealth of the nation. So, the mathematical treatment of preferred outcomes or utility was first formalized by Leon Walras and was improved by the Frank Ramsey and later by John von Neumann and Oscar Monkston in their book called it as Theory of Games and Economic Behavior. Next, decision theory, which combines probability theory with utility theory, provides a formal and complete framework for decision made under uncertainty, that is, in cases where the probabilistic distribution approximately captures the decision maker's environment. So, this is suitable for large economics where each agent need pay no attention to the action of the other agent as individual. For small economics, the situation is much more like a game. So, the action of one player can significantly affect the utility of the another. So, the von Neumann and Monkston developed of a game theory and include the surprising result that for some games, a rational agent should be adopt policies that are randomized. Unlike the decision theory, game theory does not offer an unambiguous prescription for selecting action. So, for the most part, economists did not address the third question listed above, namely how to make rational decision when payoff from the action are not immediately, but instead result from several actions taken in sequence. So, this topic was pursued in the field of operation research, which emerged in World War II from efforts in Britain to optimize a radar installation and later found in civilian application in complex management decisions. So, the work of Richard Bellman formalized a class of sequential decision problem called Margot decision processes. So, the work in economics and operation research has contributed much to our nation of rational agent, yet for many years AI research developed along entirely separate paths. One reason was apparent complexity of making rational decision. So, the pioneering of AI research, Herbert Simon, won the Nobel Prize in Economics in the year 1978 for his early work showing that model based on satisficing, making decisions that are good enough rather than laboriously calculating the optimal decision, gave a better description of actual human behavior. Since 1990s, there has been an insurgence of interest in the decision theory techniques for agent system. Next, neuroscience. Neuroscience is the study of nervous system, particularly the brain. Although the exact way in which the brain enables thought is one of the great mysteries of science, the fact that it does enable thought has been appreciated for thousands of years because of the evidence that strong blows to the head can lead to mental incapacitations. It has also long been known that human brains are somehow different in about 335 BC. So, Aristotle wrote of all the animals, man has the largest brain in proportion to his size. Still, it was not until the middle of the 18th century that the brain was widely recognized as the seat of consciousness. Before then, candidate location include the heart and the spleen. So, this is the picture of the neuron, and each neuron consists of cell body or soma that contains a cell nucleus. So, the branching out from the cell body or the number of fibers called dendrites and a single long fiber called axon. The axon stretches out for a long distance, much longer than the scale in the diagram indicates. Typically, an axon is 1 centimeter long, but can reach up to 1 meter. A neuron makes connection with 10 to 1 lakh other neurons at junction called synapses. Signals are propagated from neuron to neuron by a complicated electrochemical reaction. So, the signals control brain activity in the short term and also enable long term changes in the connectivity of neurons. So, these mechanisms are thought to form the basis for the learning in the brain. Most information processing goes on in the cerebral cortex. So, the outer layer of the brain, the basic organizational unit appears to be column of tissue about 0.5 millimeter in diameter containing about 20,000 neurons and extending the full depth of cortex about 4 millimeter in humans. So, we now have some data on mapping between areas of brain and the part of the body that they control or from which they receive sensory input. Such mappings are able to change radically over the course of the few weeks, and some animals seem to have multiple maps. Moreover, we do not fully understand how other areas can take over function when one area is damaged. So, there is almost no theory on how an individual memory is stored. So, that is most important line. So, the truly amazing conclusion is that a collection of sample cells can lead to thought, action and consciousness, or in the pithy word of John Searle, brain caused the minds. So, compare with the supercomputer, personal computer and human computer, and corresponding computational unit is for supercomputer 10 power 4 CPUs, 10 power 12 transistors, and personal computer 4 CPUs and 10 power 9 transistors, and human brain 10 power 11 neurons. So, storage unit for supercomputer is 10 power 14 bits RAM, whereas personal computer 10 power 11 bits RAM, whereas human brain is 10 power 11 neurons. So, cycle time is 10 power minus 9 seconds for supercomputer, personal computer 10 power minus 9 seconds, human brain is 10 power minus 3 seconds. So, the operation is take 10 power 15, for personal is 10 power 10 and human brain is 10 power 17. So, the memory updates for per second supercomputer is 10 power 14, whereas personal computer is 10 power 10 and human brain is 10 power 14. So, this table shows that the crude comparison of a raw computational resource available in IBM Blue Gene supercomputer, a typical personal computer of the year 2018 detected and the human brain. So, the brain's numbers are essentially fixed, whereas the supercomputers number have been increased by the factor of 10 every 5 years. So, allowing it to achieve the rough parity with the brain. So, the personal computer lags behind all the matrices except cycle time. So, the only real alternative theory is mysticism, that mind operate in some mystical realm that is beyond physical science. So, the brain and digital computers have somewhat different properties, that is figure 1.3 shows that computer have a cycle time that is 1,000,000 times faster than the brain. So, the brain makes up for that with a far more storage and interconnection than even a high-end personal computer, although the largest supercomputers have a capacity that is similar to the brain's. So, it should be noted however that the brain does not seem to use all its neurons simultaneously. So, futurists make much of these numbers point to an approaching singularity at which computer reached a superhuman level performance, but the raw comparison are not especially informative. Even with a computer of virtually unlimited capacity, we still would not know how to achieve the brain's level of intelligence. So, next to psychology. How do human and animals think and act? So, the origin of a scientific psychology are usually traced to the work of the German physicist Hermann von Helmholtz and his student Wilhelm Wundt in the year of 1832 to 20. Helmholtz applied a scientific method to study of human vision, and his handbook of psychological optics to even now described as the single most important treatise on the physics and physiology of human vision. So, the Wundt opened the first laboratory of experimental psychology at the University of Leipzig. Wundt insisted that a cognitive psychology, means which views the brain as an information processing device, can be traced back at least to the work of William James. Helmholtz also insisted that perception involved a form of unconscious logical inference. So, the cognitive viewpoint was largely eclipsed by behaviorism in the United States, but at Cambridge applied psychology unit directed by Frederick Bartlett. So, cognitive modeling was able to flourish the nature of explanation by Bartlett's student and successor Kenneth Carrick forcefully re-established the legitimacy of such mental terms as beliefs and goals, arguing that they are just as scientific as, say, using pressure and temperature to talk about the gases, and despite their being made of molecules that have neither, and Crack specified that this type of the ideas. Now, we have a computer engineering. How can we build an efficient computer? For artificial intelligence to succeed, we need two things. One is intelligence and an artifact. The computer has been an artifact of choice. The modern digital electronic computer was invented independently and almost simultaneously by scientists in 3 countries embedded in World War II. The first operational computer was electromechanical Heath Robinson, built in the year of 40 by Alan Turing team for a single purpose and deciphering German messages. In 43, the same group developed in Colossus a powerful general purpose machine based on vacuum tubes. So, the first operational programmable computer was Z3, the invention of Konrad Zuse in Germany in 1941. Zuse also invented floating point numbers and the first high level programming language Planckul, and the first electronic computer, the ABC, was assembled by John Adamsoff and his student at Iowa State University. Adamsoff research received little support or recognition. It was the ENIAC, developed as a part of secret military project at the University of Pennsylvania by a team including John Muxley and John Eckert, that proved to be the most influential forerunner of modern computers. So, Alexandria built the first self-controlling machines, a water clock with a regulator that maintained a constant flow rate. This invention changed the definition of what an artifact could do. So, previously only living things could modify their behavior in the response to change in the environment. So, other example of self-regulating feedback control system include the steam engine governor created by James Watt, and the thermostat invented the Cornish Drebbel, who also invented the submarine. So, the mathematical theory of a stable feedback system was developed in the year of 19th century. So, the central figure creation of what is now called control theory was Norbert Wiener. Wiener was a brilliant mathematician who worked with Bernard Russell among others. Before developing an interest biological and mechanical control system and their connection to cognition. Therefore, the like Craig, who also used control system as a psychological. Now, the model control theory, especially the branch known as stochastic optimal control, as its goal the design of system that maximize an objective function over time. This roughly matches overview of AI. So, the designing system that behave optimality, why, then, or AI and control theory, two different fields. Despite the close connection among their founders, the answer lies in the close coupling between the mathematical techniques that were familiar to the participants and the corresponding sets of problems that were encompassed in each worldview. So, the calculus and matrix algebra, the tools of control theory, lends themselves to systems that are describable by fixed sets of continuous variables, whereas AI was founded in the part as the way to escape from these perceived limitations. So, the tools of logical inference and the computation allowed AI researchers to consider problems such as language, vision and planning that fell completely outside the control theory's purview. So, next linguistic. So, the Skinner published in the verbal behavior, this was the comprehensive detailed account of the behaviorist approach to language learning written by the foremost expert in the field. But curiously, the review of the talk became well known as the chapter itself and served to almost kill off the interest in the behaviorism. So, the author of review was the linguistic Noam Chomsky, who had just published the book on his own theory of syntactic structures. Next is the state of art, robotic vehicles. So, the driverless robotic car named Stanley sped through the rough-free terrain of the Mojave Desert at 22 mph, finishing the 132 miles course first to win the 2005 Darba Grand Channels. Stanley is a Volkswagen Touareg outfitted with the cameras, radar and laser rangefinders to sense the environment and onboard software to command the steering, braking and acceleration. So, the following year CMU's Bose won the urban challenge, safely driving in traffic through the streets of closed Air Force Base and obeying traffic rules and avoiding pedestrian and other vehicles. Next is speech recognition. A traveler called United Airlines to book the flight can have the entire conversation guided by an automated speech recognition and dialogue management system. So, next autonomous planning and scheduling. 100 millions from the earth of NASA's remote agent program became the first on board autonomous planning program to control the scheduling of the operation for the spacecraft. So, the remote agent generated plans from high level goals specified from the ground and monitoring the execution of those plans, detecting, diagnosing and recovering from problems as they occurred. And a successor program MapGen plans the daily operation for NASA Mars exploration rovers and Mexos did mission planning, both logistic and science planning for the European Space Agency Mars Express mission in the 2008. Next, game playing. IBM's Deep Blue became the first computer program to defeat the world champions in chess match when it bested Kasparov by the score of 3.2 to 2.5 in the exhibition match. Kasparov said that they felt a new kind of intelligence across the board from him. The Newsweek magazine described the match as the brain lost stand. So, the value of IBM stock increased by $18 billion. The human champions studied by Kasparov lost and were able to draw a few matches in subsequent years, but the most recent human computer matches have been won convincingly by the computer. Next is spam fighting. Each day the learning algorithm classifies over the billion messages as spam, saving the recipient from having to waste time deleting that, what for many users could comprise 80% or 90% of all messages, if not classified away by algorithm, because the spammers are continually updating their tactics. So, it is difficult for a static program approach to keep up the learning algorithm work best. So, next is logistic planning. During the Persian Gulf crisis, the US forces deployed a dynamic analysis and a replanning tool, DOT, logistic planning and scheduling for transportation. So, this involved up to the 50,000 vehicles, cargo and people at a time, and had to account for starting points, destination, routes and conflict resolution among all parameters. So, the AI planning techniques generated in hours a plan that would have taken weeks with older methods. So, the Defense Advanced Research Project Agency stated that the single application more than the paid back of DARPA's 30 years investment in AI. Next to robotics. The iRobot Corporation has sold over 2 million Roomba robotic vacuum cleaners for home use. The company also deploys the more rugged PackBot to Iraq and Afghanistan, where it is used to handle hazardous materials, clear explosive and identify the location of the snippers. Next, machine translation. The computer program automatically translates from Arabic to English, allowing an English speaker to see the headline Erdogan confirms that Turkey would not accept any pressure, urging them to recognize Cyprus. So, the program used a statistical model built from example of Arabic to English translation and from example of a English text totaling 2 trillion words. None of the computer scientists on the team speak Arabic, but they do understand statistics and machine learning algorithm. So, now we have an application related to this. So far real time problem discussed, and let us go into discuss the application of mathematics in AI. Number 1, introduction to application of mathematics AI plays a crucial role in the development and application of AI. So, mathematics algorithms are used to process and analyze data in AI system. So, mathematical model are used to solve the complex problem in AI, and mathematical foundation of AI or linear algebra is used to represent and manipulate data in AI such as vectors and matrices. Calculus is used to optimize AI model and algorithms such as gradient descent, that already we discussed, and probability theory also discussed, and statistics also we discussed. So, probability theory and statistics are used to analyze uncertain and make the informed decision in AI system, and machine learning and statistics rely on statistical method to learn from data and make a prediction. Probability theory is used to model uncertainty in machine learning algorithm, and statistical hypothesis testing is used to evaluate the significance and performance of AI model. And neural network and calculus. Calculus is used to train neural networks by optimizing their weights and biases. Already discussed the gradient descent. So, using this descent, calculus based optimization algorithm is used to minimize the loss function in neural network. So, calculus is used to calculate the gradients and update the model parameter during the training using the graph networks. And next, the natural language processing and probability theory. So, probability theory is used in natural language processing for language modeling and text generation, and we are using the hidden Markov model. A probabilistic model are used for speech recognition and part of a speech tagging, and Bayesian method are used to infer the meaning of ambiguous words or phrases in natural language processing task. And for the computer vision and geometry, so the geometry is used in computer vision to represent the manipulate 3D object and scenes, and transformation matrix and homographics are used to project and align images in computer vision tasks, and differential geometry is used to analyze and model curved surface in computer vision application. So, this is the 2D recognition and 3D localization and corresponding 3D voxel patterns. And next to robotics and kinematics. So, kinematics, a branch of mathematics, model and control the motion of the robots. So, it forward and inverse kinematics equation are used to compute the position and orientation of robot joints, and robotics algorithm rely on mathematical model to plan and optimize the robot, that is explained. So, this is the desired location, we have to check it out. and this will be helpful for the mathematical tool in robotics. Next, optimization and operation research. Optimization algorithms such as linear programming and dynamic programming are used to solve the complex optimization problem in AI that we discussed in unit 3. So, the operation research techniques are used to optimize resource allocation and scheduling in AI system, and mathematical optimization is used to improve the efficiency and performance of AI algorithm. For data mining and graph theory is used in data mining to analyze the relationship between the data points. So, graph algorithms such as PageRank and community deduction are used for recommendation system and social network analysis. So, graph theory also plays a role in network analysis, anomaly detection in AI application. So, that is what we have a neural network that already demonstrated, and check it out, and social network also will be already demonstrated theoretically. So, that where the AI's application is helpful. Then conclusion. So, mathematics provide a foundation for algorithm and model. So, the application of mathematics in AI enables the development of intelligent systems and decision making process. So, continued advances in mathematics further enhance the capabilities of AI technologies. Thank you.